Hi, welcome back to part 3. So in part 2, we've estimated the fair value of Coca-Cola using the average dividend yield. In part 3, we're going to make the code easier to read, we'll add some comments and error handlers, and calculate the fair value based on an average surplus yield. This approach is not a standard model, it's just something that I've come up with for the purposes of this example. We start by calculating the difference between the dividend yield and the 10-year Treasury bond yield, and we do this for all periods. We'll then take the average of these surplus yields and add it to the latest 10-year Treasury bond yield to get an expected dividend yield and use it to estimate the value per share. Let's now switch back to the website and open another code editor. Navigate to Models, Public Repository, Model Presets and Tutorials, and select the Model Starter preset. The lines that begin with a double slash are single line comments. We'll use single line comments to separate the code into a couple of sections: the assumptions section, key values section, the charts section, and the table section. I'll copy them into our model. We now have the code split into different sections, and it will be easier to follow through as the code gets more complex. Let's now add an error handler that will throw an error if the selected company doesn't pay dividends. We'll choose Tesla as an example. Let's input ticker TSLA, click Run, right-click, choose Inspect, go to the console, and notice the error dividend slice is not a function. This is because Tesla doesn't pay any dividends and the computer doesn't have anything to slice, and it should log an error to the screen instead. We'll verify if the company pays dividends before the slicing begins. Right after we create copies, add an if statement. If not dividends dot length, we will log the error using the error function. This company doesn't pay dividends, and we'll return to avoid further execution. Let's save it and test it again. Click Run, and we can see that the error is now being logged to the bottom console and to the output window as well. Now, there's another problem. Notice the historic years are 10 by default, but if the company doesn't have 10 years of dividend history or price history, it will still slice the reports inconsistently. Let's see what happens if I run the model on the Ferrari company with ticker RACE. You can see that there are 6 annual dividends and 8 annual closing prices. This is because Ferrari's IPO was back in 2015 and we're in 2022, so there's not enough data. To overcome this, let's set the historic years to the minimum length between the two reports. We can achieve this using dynamic assumptions. Documentation for assumptions can be found in the developer's guide, valuation functions, setting assumptions. The function which we'll use is the setInputDefault function. It is used to set the default value of dynamic assumptions. Notice that we need to remove the static value and add double apostrophes. Let's go back to our model. Delete the static value for historic years and add the double apostrophes. Let's call the setInputDefault function. The first argument is the name of the assumption, or historic years. Second argument is the value. We'll use math.min to set the minimum between the dividends length, the prices length, and the value 10. Let's save, clear the console, and run it again. can see that the lengths of the reports have changed to 6. If we open the output window, the historic years are now set to 6 by default. I'll take the assumption section comment and move it up here to mark the beginning of the assumptions. Let's now set a few more dynamic assumptions which we're going to use. The first is the average dividend yield. This is a rate, so we'll start with an underline. Next is the average surplus yield. And the final one is the risk-free rate. Let's first set the average dividend yield to the value that we've calculated down below. Take the input and find the average dividend yield calculation. Now we'll use the set input default function once again. Set the average dividend yield to the calculated value. And let's use the value from the inputs in the calculation of the value per share. And also in the print function. Let's save and open the model in company valuation. So we've actually forgot to multiply the input by 100 to convert it to a rate. So let's get back to the model and use the function that converts a number to a rate called toR. Save and go back to the company valuation and refresh. Now the average dividend yield is correctly set. If we change it, the estimated value should automatically update. Let's now calculate the surplus yield. We'll create an array of yields of the 10-year Treasury bond. We'll name it Treasury Yield. Let's expand the last Treasury object and copy the year 10 property and add it as its first value to our array. This yield is in rate format already, but we'll need to convert this to a number or divide it by 100 in order to be compatible with all other rates. I know this sounds a bit confusing, but even though we've converted the average dividend yield to a rate, meaning that we've multiplied it by 100, when we retrieve it by calling input.average dividend yield, the value is actually in a number format. So let's convert the first element to a number using the toN function. And let's make an array of surplus yields. The first element being the last dividend yield minus the last yield of the 10-year Treasury bond. And let's push the rest of the elements in the arrays inside the for loop. Treasury yields dot push. Let's expand the Treasury yields, the first object. And in order to get the correct index, we need to understand that the program will access this code contained in the if statement only for I greater than or equal to 1, because the first dividend date, or LTM, is not equal to 2022, so it will skip the first iteration. So we'll push the Treasury with index I shifted by 1 dot year 10, and we'll have to convert this to a number. I've actually realized I've made a small mistake here. This should be last Treasury. And now let's calculate the surplus yields and push them into the array. Surplus yields dot push the dividend yield minus the 10-year Treasury bond yield. We'll calculate the average surplus yield in the same manner as the average dividend yield. So we'll copy this line and paste it down below. And let's set the input to the calculated value. We'll also need to set the risk-free rate to the latest 10-year Treasury bond yield. This time we can leave their value in the rate format. Let's try to run this to make sure we've set the inputs correctly. Clear the console and press run. If we open the output window, we can see the assumptions look correctly set. Now let's print the expected yield. The expected yield is the sum between the average surplus yield and the risk-free rate, or the 10-year bond yield. We'll name it expected dividend yield. And we'll display it as a rate. And we'll also print the estimated value of the surplus method. We'll take the last 12 months dividend divided by the expected dividend yield. We'll label it as estimated value, average surplus yield. Close it. Let's clear the console, save the model, and run it again. Click on the output window, and you can see the estimated value here. We can round this value using the number formatting of the print function. Add the third argument, and hit run again. In the next video, I'll show you how to create charts and tables with the data that we've calculated in part 3. So, see you in the next video.